Good morning, students. We shall continue the previous topic, how to identify whether the given signal is energy signal or power signal, or neither energy signal or not power signals. Okay. So we have solved very few problems in continuous time signal as well as discrete time signal. So in this class, I'll be solving 6 more problems. Then we will move on to the next topic. Okay. Right. Problem number 1, x of t equal to e power j 2t plus pi by 4. Okay. E power j theta, complex exponential signal. So whether the signal is periodic or aperiodic first. Because already I told you some clue to identify the given signal is energy or power. Is this periodic or aperiodic first?
Periodic too.
Okay. If periodic signal meaning most of the cases, it may be the
Power signal.
fast is a periodic signal. It may be the power. Then remaining all the signal u, t, t minus 1, r of t, this 1 plus e power minus 5t exponential and unit step. So remaining all 3, 4, 5, 6, these signals may be example for energy. But anyway, we have to check. Okay, we have to check. Sometimes you will get neither energy signal nor power signal. That condition may not satisfy for both the cases. That time you have to write the comment. The signal is not an power signal and also energy signal. For example, the last signal, I will show you the result of energy and power of x of t equal to t times of u of t. So problem number 1, x of t equal to e power j 2t plus pi by 4. Formula to find the energy of that continuous time signal minus infinite to infinite modulus x of t square dt. So in this example, minus infinite to infinite e power j 2t plus pi by 4 modulus into dt. So we know that e power j theta equal to cos theta plus j sin theta. So modulus of minus infinite to infinite modulus e power j theta. It is similar to modulus e power j theta. So e power j theta equal to cos theta plus j sin theta. So if we find the modulus for this, then you will get square root of cos square theta plus sin square theta. The value is 1. So the result is 1 dot dt. So 1 dot dt, you will get t minus infinite to infinite. The energy of the signal will be infinite. Now calculate the power of the signal. What is the formula to find out the power of the signal? Power limit t tends to infinite 1 divided by 2t integration minus infinite to infinite x of t square dt. Here x of t square dt equal to 1. Sorry, minus t to t. Minus t to t. Finally, you have to substitute t tends to infinite. Minus t to t x of t square dt. X of t square in this example 1. 1 dot dt. Limit t tends to infinite 1 by 2t. Simplify this and try to check whether this the t term is cancellation possible or not. So you'll get t. Okay, you'll get t dt integration with respect to t. You'll get minus t to t. So t minus of minus t 2t. Limit t tends to infinite 1 by 2t. You'll get 2t. Okay. So the 2t will be cancelled. Then there is no possibilities of substituting t tends to infinite. So the power value is 1 watts. Okay. Here energy equal to infinite. So what is the conclusion? e power j 2t plus pi by 4. For this signal, energy is infinite, power is finite. Conclusion. Energy of this particular signal is infinite. Energy of this particular signal is infinite for this example. And power of this particular signal is finite, that is 1. Therefore, the given signal is power signal. Therefore, the given, sorry, yeah, correct. Yeah, correct. Therefore, the given signal is power signal. Power finite, energy infinite. Okay. So this you can guess from the given signal itself. E power j theta complex exponential signal. The individual complex exponential signal is always periodic. So most of the time, the periodic signal may be the power signal only. Okay. Second problem, x of t equal to cos t. X of t equal to cos t. Problem number 2. X of t equal to cos t. Find the energy of the signal. Minus infinite to infinite. X of t square theta. So cos square theta. Okay. Cos square theta. So you will get cos square t into t. So minus infinite to infinite. Cos square theta. 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2. So take 1 by 2 common outside. Minus infinite to infinite. 1 dot dt plus minus infinite to infinite cos 2t dot dt. Okay. So in this kind of problems, first check the first term, 1 by 2 minus infinite to 1 integration dt. So you'll get t, then substitute the limits, lower limit minus infinite, upper limit minus infinite, then definitely you will get infinite. For the first term, result would be infinite. Okay. So infinite plus anything. Infinite. So no need to solve the second step. I can put energy equal to infinite. Okay. Cos 2t, then you'll get sine 2t, then sine of infinite value between minus 1 to 1. So no need to worry about the second step. In first step itself, we confirmed that this result would be infinite. So infinite plus anything, the result will be infinite. Okay. Similarly, to find out the power of the particular signal, limit t tends to infinite 1 by 2t. Integration minus t to t 1 plus cos 2t by 2 dot dt. So limit t tends to infinite 1 by 2t. I'll split this expression. Okay, minus t to t 1 by 2 dt plus limit t tends to infinite 1 by 2t integration minus t to t cos 2t by 2 dt. Okay, so check the first term now. Limit t tends to infinite 1 by 2t. First term 1 by 2 t dt with dt, if you differentiate with respect to t, you will get small t minus t to t. Okay. The second step, is there is any possibility of cancellation of this t? Cos 2t, you will get sine 2t. Then sine of t and sine of minus t only. So let it be. Second term let it be. We will concentrate first term first. limit t tends to infinite 1 by 2t in 1 by 2. Okay. Capital T minus of minus t, you'll get 2t. So in the first term, this t will be cancelled. Particularly, this 2t will be cancelled. So there is no capital T terms. So we cannot substitute t tends to infinite. So result is 1 by 2. From the first term, the result is 1 by 2. Okay. From the second term, without integrating this particular function, you just check is there is any possibilities of cancellation of this t. If you do the integration cos 2t, you will get sin 2t. Then substitute lower limit, upper limit, sine of 2 capital T minus sine of 2 minus capital T. Okay. So there is no possibilities of cancellation of this t. So at the final step, if you substitute t tends to infinite, 1 by infinite will be 0. So you can directly substitute 0 over here. No need to do the integration completely for the second term. Okay. Right. So now power of this particular signal 1 by 2 watts. Energy of this particular signal infinite. So power of this signal is finite. Energy of the signal is infinite. Therefore, this signal is power signal. What is the definition for power signal? The power of the signal must be finite. Energy of the signal must be infinite. Therefore, the given signal is power signal. This way I have to solve. So first two example completed. E power j theta is a periodic signal. So it's a power signal. X of t equal to cos t is a periodic signal. And we proved that it is a power signal also. Next, u of t minus u of t minus 1. U of t minus u of t minus 1. Okay. Problem number 3. X of t equal to u of t minus u of t minus 1. So for this signal, first we have to sketch the signal for x of t properly. Okay. So what is u of t signal? Signal sketch for u of t minus infinite to 0, 0, 0 to infinite. The value is 1. This is time axis. And u of t minus 1 from 1 to infinite, the value is 1. From minus infinite to 1, value is 0. So if you subtract u of t minus u of t minus 1, then your signal would be like this. Between 0 to 1. Between 0 to 1, 1 minus 0, 1. So from minus infinite to 0, 0. From 1 to infinite, 0. So between 0 to 1, your value is 1. So now for the power and energy formula, we have to change the integration limit. For example, energy equal to integration minus infinite to infinite x of t square dt is the general formula. Minus infinite to infinite modulus of x of t square into dt is the general formula. But for this particular problem, the signal is valid between 0 to 1 only. So 0 to 1 x of t square dt. Now x of t magnitude 1 only. So 1 square into dt. Okay. So if we find the energy, you will get 1 joules. And power of this particular signal, limit t tends to infinite, 1 by 2t, integration 0 to 1. Sorry. Yeah, integration 0 to 1. Correct. If it is 0 to infinite, then you will get 0 to t. For this example, you have to substitute 0 to 1 only. So 1 square dot dt. So limit t tends to infinite, 1 by 2t. Your answer is 1. Okay. So now substitute t tends to infinite, 1 by infinite, 1 by infinite value is 0. 1 by infinite value is 0. So for the third signal, energy is finite. Energy is finite. And power of the signal is 0. Power of the signal is 0. So this is the condition for a signal to be energy signal. Therefore, the given signal is energy signal. Okay. So similarly, you try to solve the problem for x of t equal to r of t minus r of t minus 2. We have to do the signal sketch for r of t first, and then r of t minus 2. Subtract r of t minus 2 signal from r of t and check the limits. Okay. Right. So what is the problem number? I think 4. Correct. So x of t equal to r of t minus r of t minus 2. So many problems are available. So we see the reference books, Signals and System by Ramesh Babu textbook, as well as Signals and System by Opinion textbook. Okay. For these kind of signal, how to check the integration limits? R of t signal, it's a ramp signal. How to sketch for R of t? T equal to 0, magnitude 0. T equal to 1, magnitude 1. T equal to 2, magnitude 2. T equal to 3, magnitude 3. So your signal will go like this. Correct? This is R of t. R of t minus 2, the signal is delayed by 2 unit of time. Or the R of t signal right shifted by 2 unit of time. So 0, 1, 2. Signal starting from 2 onwards. That is this magnitude 0. At 3, the magnitude is 1. At 4, the magnitude is 2, and so on. Now sketch the signal for R of t minus R of t minus 2. R of t minus R of t minus 2. 0 to 2, no information available. So 0 to 2, whatever information is there, let's say x, this is the x. X minus 0, x. So 0 to 2, no change. The same signal, okay, minus 0, you will get this pattern. 1, comma 2, right? So at 2 to 3, say for example, at 2 here it is magnitude 2, 2 minus 0, 2, okay. At 3, the magnitude is 3. Here at 3, t equal to 3, magnitude 1, so 3 minus 1, 2. 3 minus 1, 2. So at 4, magnitude 4. At 4, magnitude 2. 4 minus 2, 2. Okay. And check for 5. Here it is, you will get 5, magnitude 5. And here you will get 3. 5 minus 3, 2. And so on. So for entire value of t, if t is greater than 2, you will get a constant magnitude of 2 for this particular signal. So from 0 to 2, this kind of signal, 2 to infinite, the magnitude of the signal is 2. Okay, that's why I take this signal to explain to you. You may get any kind of signals. Sketch the signal properly, then only you can identify the integration limits. So for this signal, let me derive energy of the signal first. General formula minus infinite to infinite modulus x of t square into dt. But in this example, minus infinite to 0, no information available. Okay, so negative value of t, no information. 0 to 2, 0 to 2, the signal follows a ramp signal, that is t function. 0 to 2, the signal follows t function, r of t function. What is r of t function? Or mathematical representation, r of t equal to t when t is greater than 0. 0 otherwise. So in the resultant signal, 0 to 2, the function represented by r of t equal to t. So t square into x of t square into dt. Plus 2 to infinite. 2 to infinite. A constant magnitude of 2. A constant magnitude of 2. So x of t square into dt. Okay. So 0 to 2 t square dt plus 2 to 4 2 square into dt. Solve it. So 2 times t square, do the integration. You'll get some value and after substitution of the limits. But in the second term, 4 integration 2 to infinite. Okay. 4 integration 2 to infinite. Say for example, 4 integration with respect to dt, you'll get t. 2 to infinite. So if you substitute infinite value for t, this entire term will be infinite. Infinite plus anything, your value is infinite. Okay. Here you will get 8 by 3. Energy equal to infinite for this signal. R of t minus R of t minus 2 signal. Energy you are getting infinite here. Now power of the signal. Limit t tends to infinite. 1 divided by 2t. Integration 0 to 2 t square plus 2 to capital T. Guess a t tends to infinite. So 2 to capital T. 4 into t. Okay. Now try to solve it. Limit t tends to infinite. 1 by 2t for the first term. You solve this value, you will get 8 by 3. Okay. 0 to 2 directly. Okay. Second term integration 2 to t 4 into, so 4 outside t 2 to capital T. So limit t tends to infinite 1 by 2t, first term 8 by 3. Plus second term limit t tends to infinite 4 capital T minus 2, 1 by 2t. Okay. So further just expand these equations equal to limit t tends to infinite 1 divided by 2t 8 by 3 plus limit t tends to infinite 1 by 2t 4 into t 4 into t, so 4t by 2t. So in this term the t will be cancelled. So sorry, formula limit t tends to infinite 1 by t 4t, okay, minus limit t tends to infinite 1 divided by 2t 4 times of minus 2, so minus 8. Now check the three terms. First term, there is no t value here, so t cannot be cancelled, so t tends to infinite 1 by infinite 0. Second term, the t cancelled, okay, so 2 times of 2, so there is no t terms, the answer is 2. Third term, t is not cancelled, so t tends to infinite 1 by infinite 0, the value is 2 watts. Okay. Check the signal. The given signal is r of t minus r of t minus 2. This is not a periodic signal, but as per the definition for energy, we solve the energy of the signal, that is infinite, and we solve the power of the signal, that is finite. So power is finite. Power is finite and energy of the signal is infinite. Therefore, the given signal is power signal. Okay. So different types of problems we are solving. If the problem given in terms of simple signal sketch ut minus 1, then how to solve it? R of t minus r of t minus 2, the integration you have to solve in two different limit, because 0 to 2 one kind of function, okay, 2 to infinite a constant magnitude of 2. So this is two-step process, right? So I think we solved all the problem. Okay. X of t equal to 1 plus e power minus 5t dot u of t. We can solve this problem similarly, like problem 4. Okay. X of t equal to 1 plus e power minus 5t ut. So ut given, so your integration limit will be changing from 0 to infinite. Separately solve this section, and identify energy of the signal and power of the signal. You try by yourself. For this particular signal, you will get energy equal to infinite and power of the signal equal to 1 by 2 watts. While calculating the power, you have to follow this procedure. Individually, while solving, individually spread the terms and check is there is possibilities of cancellation of this t. At final step, you have to substitute t tends to infinite. If you follow the same procedure for the next problem, you will get energy equal to infinite, power equal to 1 by 2 watts. So this is your energy signal. Sorry, power signal. Power equal to 1 by 2 watts. So energy equal to infinite. So this is a power signal. Okay. So all we cannot comment all the periodic signal may be the energy signal. Possibilities are there most of the cases. So the 4, 5s are exceptional cases. Problem number 4, 5. This is also a periodic signal. This is also a periodic signal. But as per the energy and power calculation, we concluded the signal 4 and 5s are power signal. Okay. Please try by yourself. Problem number 5. Last one. X of t equal to t dot u of t. I'll solve this because this signal is an example of neither energy signal nor power signal. Problem number 6. x of t equal to t dot u of t. Energy of the signal, formula integration minus infinite to infinite, modulus x of t square into dt. Now integration u of t. U of t signal valid from 0 to infinite value 1, minus infinite to 0, 0. So from minus infinite to infinite, integration limit now changes from 0 to infinite. U of t value 1, 1 dot t, t square dot u of t, because x of t square. So you'll get t square dot dt. Ut value 1, 1 square dot 1. So t square integration 0 to infinite dt, then you'll get infinite only. So energy of the signal is infinite. Now check for power of the signal. A limit t tends to infinite, 1 divided by 2t. 0 to t. Okay, 0 to t, t tends to infinite. Then t square dot dt. Okay. Limit t tends to infinite, 1 by dt. Now check t square dt. What you will get? T cube by 3. So 0 to t. Correct. Okay. Now they written here. Okay. Limit t tends to infinite, 1 by dt. Integration 0 to t, t square dt. Okay. Okay. T cube by 3. Okay. So limit t tends to infinite, 1 by 2t. Okay, right. T cube, t cube by 3. Okay. Lower limit 0. Lower limit 0. So this t cancel, t cancel, t square will be available. Now substitute t tends to infinite. Now substitute t tends to infinite. You will get infinite. Correct? 1 by infinite only 0. This t will be cancelled. So t square by 3 available. So if you substitute t tends to infinite, power also infinite. So in this last signal example, t times of ut, energy we got for infinite value, and power of the signal also infinite value. Energy of the signal infinite and power of the signal also infinite. So from this information, we cannot conclude whether this is energy signal or power signal. Therefore, therefore, the given signal is therefore the given signal is neither energy nor power. Neither energy nor a power signal. Okay. So got it? How to solve energy signal and power signal? So any doubt? So I will upload this written PDF in the Google Classroom. Once I completed the first half of the syllabus, still some portions are there. So are you clear about this topic? Energy signal, power signal, and how to calculate energy signal and energy of the signal and power of the signal. Shall we move on to next topic? So, what are the remaining two classification signal classifications? Periodic, aperiodic we completed. Even signal, odd signal we completed. Energy signal and power signal we completed. And some more definition available. Whether the signal is causal and non-causal signal. Okay, causal and non-causal signal. Next classifications. The classifications of signal, causal and non-causal signal. So what is the definition for causal signal? A signal is a causal signal if x of t equal to 0 for t less than 0. Okay, x of t, there is that meaning there should not be any information in the negative value of t. That is causal signal. Non-causal signal. X of t equal to 0 for t less than 0. The condition for causal signal. Otherwise, non-causal signal. Okay. That represents if there is information available in the negative side also, as well as positive information, then it is non-causal signal. So we cannot write on separate definition for this. X of t equal to 0 for t less than 0. Then the signal is partial signal. Otherwise, non-causal signal. Otherwise, this signal is non-causal signal. Particularly, even for t less than 0 also, if x of t is non-zero value, then that particular signal called as non-causal signal. So you can understand this definition with some example. Say for example, x of t equal to e power at dot u of t. Okay. X of t equal to e power at dot u of t. So u of t signal multiplied with some function e power at. So we know the sketch for u of t minus infinite to 0, 0, 0 to infinite value 1. So if this signal multiplied with e power at, then the resultant information definitely must have the information between 0 to infinite only. Yes or no? E power at. If you try to plot e power at signal at t equal to 0, magnitude 1. At t equal to 1, 2, you will get exponentially growing positive t value of t. For the negative value of t, e power minus 1t. So e power minus 2t. Then you will get decreasing exponential. When you multiply these two signal, e power at dot u of t, then your signal sketch would be starting is 1. Because 1 dot some value will get same kind of. So e power at u of t. It has 0 information, the negative values of t. That is the definition for causal signal. X of t equal to 0 for t less than 0. Okay. So this signal satisfy the condition. There is no information or magnitude for this x of t during t less than 0. So this is a causal signal. This is a causal signal. Identify whether the following signal is causal or non-causal signal. Okay. So example 2, x of t equal to e power minus 2t dot u of minus t. What is u of minus t? Signal sketch for u of minus t. Time reverse reversion of your ut. From minus infinite to 0, magnitude 1, and 0 to infinite, magnitude 0. If this signal multiplied with the e power minus 2t function, definitely you will get the information. Let's sketch e power minus 2t signal. E power minus 2t. T equal to 0, magnitude 1, e power 0. If you substitute t 1, 2, 3, and so on, then you will get decreasing exponential. If you substitute minus 1, minus 2, minus 3, e power minus 2 multiplication with minus 1. So e power 2 and e power 4 like this. Negative value of t, it is increasing exponential. Now multiply these two signal. What is your e power minus 2t u of t? Minus 1, minus 2, and so on, up to minus. So x of t value non-zero. X of t value is non-zero for t less than 0. Therefore, this signal is example for non-causal signal. This signal is an example for non-causal signal. So similarly, whatever may be the given signal, in discrete case also, draw the sketch. If there is any information present, negative value of t, then the signal is said to be a non-causal signal. Okay. For the negative value of t, the magnitude of the signal is entirely 0, then that signal is said to be a causal signal. That's all about causal and non-causal. You can expect any kind of signals. Based on the signal, you comment on that, whether it is causal or non-causal. So energy signal, power signal, periodic signal, aperiodic signal. From those topic only, you can expect the problems. Remainings are very easy only. Even signal, odd signal also. And finally, one more classification. What do you mean by deterministic signal and random signal or non-deterministic signal? This is another classifications of signals. Discrete signal, continuous time signal, periodic, aperiodic, even signal, odd signal, energy signal, power signal, causal, non-causal signal, deterministic and random signal, or deterministic or non-deterministic signal. Okay. So what do you mean by deterministic signal? A deterministic signal is a signal exhibiting no uncertainty of value. Okay. Or a signal is can be represented by the mathematical equations. Example I'll give you. X of t equal to a sine omega t. A sine omega t. Okay. Signal. Or x of t equal to u of t. X of t equal to r of t. X of t equal to u of t plus u of minus t. Something like that. Okay. So can be represented by mathematical model or mathematical equation. So those kind of signal called as deterministic signal. Random signal, we cannot represent the random signal by the mathematical equations. Usually, the noise signals in the communication system is an example for the random signals. Okay, I'll give you some example. Suppose if the signal is like this. Okay, so you cannot represent the mathematical equation for this kind of signal. It's uncertainty. So in this example, we can conclude at t equal to 0, what is the magnitude? At t equal to some kind of mathematical equation we can write. But random signal is the one we cannot give the mathematical model for that particular signals or mathematical equations we cannot use. Those kind of signal called as random signals or non-deterministic signal. Okay. Signal can be represented by mathematical model. Mathematical equations. Okay. So up to this particular step, the classifications of signals are completed. After completion of the basic operations of signal in both discrete as well as continuous cases, then the classifications of signals. Discrete signal, continuous signal, and periodic, aperiodic. And we have solved many problems in periodic and aperiodic signal, both continuous as well as discrete time signal. Then energy signal, even signal and odd signal. That is also very important. In power signal, energy signal, causal and non-causal signal. Finally, deterministic signal and random signals. Okay, right. So along with this, some basics are available in Unit 1.